I'm very happy to introduce Elin Ehsani, who is representing Finland, and she works for. I just realized I don't know whether to say Silo AI or Silo AI, but I hope that you can correct me on this. And as you're going to say a few words about yourself, I'm going to skip this. So please take it away and welcome.
Thank you, Galina. So I am Elin Ehsani. I have started working on NLP since 2012 during my master. And then after that, I finished my PhD in Işık University in Turkey, again in NLP field. And then I came to Finland. I continued research and postdoc at the University of Helsinki in creating syntactical parser, which is a branch of NLP. And after that, I am working in different consultancy companies for last 4 years, and mainly on natural language processing. The company that at the moment I am working is Silo AI, but Galina, Silo AI also is the name that many people are using. That I wouldn't say that it's wrong. So Silo AI is the largest private AI lab in the Nordic, with 240 different experts, which half of them have a PhD in the field. And Silo is providing consultancy services for the different companies in field of AI. So today I'm going to talk about two different industrial use cases that I have been using natural language processing algorithms to solve the problem. In Silo AI, we have different type of customers from industry, manufacturing industry, for example, non-profit organization, universities, public sector, which all of them have their own problem, and they want to automatize their process. They want to ease their employees' labor, or they want to use AI to optimize some process. So I hope at the end of this presentation you can get some takeaway related to how is more generally how is ML in industry, what should be focused, and what are side steps that we should be aware of them when we are using ML in real life. So when it comes to machine learning, nowadays, rightfully, deep neural networks are very, very popular, and they produce state-of-art solution for many problems, and it seems that they might solve all kind of problems, and this leads many engineers all over the world be forced to use them regardless of the nature of the problem. But we should know that machine learning is a rich field with a long history of many algorithms which are still useful and we can still trust. So we can talk about kind of an AI toolbox that we have different algorithms there, because for different kind of problem we are gonna need different types of when we have different kinds of problems and different kinds of data, then we need different kinds of algorithms to solve them. not just one. So, for example, if your problem is defined like this, that you have a prescription which you should extract 4 different entities from them, and you already have 200 annotated prescriptions, it makes sense that you start with some traditional machine learning algorithms. For example, in this case, a conditional random field model will give you 95 percentage of accuracy. So you don't need to be worried about like using GPU or using any other resources. So we can let's say that if we assume that we know nothing about the problem, other than that the observation come from some probability distribution. So no free lunch theorem states that average test error of different machine learning algorithms are all equal. So a billion parameter deep neural network performs on average as well as guessing a constant value. So the average is taken over all possible data generating distributions. We know nothing, so subjectively, they are all equally probable. So what is the moral of the story here is successful machine learning requires a deep understanding of a given problem beyond what is provided in training set. So I'm sure most of you know about overfitting, and it could be your nightmare in some stage of your research or your work. So like this kind of phenomenon in machine learning cause that we should be careful in choosing not only the right kind of the model, but also the right complexity. This is a well-known phenomenon in machine learning, which is related to discrepancy between training and test error. Especially when you have a complicated model, then you observe a great training error compared to like very awful results in test set. So let us develop this intuition a bit in next slide. So here there are many mathematical theorems that we can explain overfitting with those, and one of them is Wapnick-Chervonenkis theory, which is very old theory, by the way, but it's about how to measure. It's about how to measure the complexity of an algorithm. And when it comes to overfitting, if we talk about this difference between train set error and test set error, then with this theory, we know that this deviation is related to two factors: the size of data and the complexity of the model. So if you have a very complex method, it will require a lot of data to be probably approximately correct compared to less complex model. So before jumping to our two use cases that I want to share with you, I want to tell that like this slides that so far I was presenting are all about this, that we should be careful what kind of algorithm we are choosing, what kind of data do we have. We should be so familiar with the nature of the problem that we want to solve. Otherwise, it's gonna be so costly when you are like when you are using like a company's hours to produce something. So this is the other important thing is, okay, we know about this, but how we normally map a real life problem for example, to an NLP problem. Because normally customer doesn't come with a problem even. They know that they want to use AI to do something, for example, to optimize something, to generate something, but they don't have precise problem, or they don't have well-defined problem that you, after like one meeting, you can just like map the problem with like a machine learning program. So let me give you an example here. We had a customer in Silo, a non-profit organization. They had this annual reports from different countries, a very long reports that their few employees had to go through them and read them carefully and extract something. So they came us and they said that we want to have summarization for long documents. So first question was, why do you want this? They said that to see important parts of report. Okay, then we asked, what part is important in your reports? And then they said that we want to find answers to our questions, actually. Then like we asked, like, could you give an example? And they said that, for example, how many people are using the product X? So it's not a summarization problem anymore. It's actually a name entity recognition problem. So after like having some long discussion, we decided to change problem from summarization problem to name entity recognition problem. So now, finally, I will go to the essential part of this talk, which is two different use cases in industry. And I will start with use case one. A company with name My Speaker, I allowed it to use this name, which they are a great company with a great owner, actually, a very knowledgeable person, which they are giving coaching service for public speakers. They come to Silo AI and ask us to automatize and productize their service using AI. That was very interesting, because at the beginning you think that how you can use AI or NLP in like for coaching a public speaker. So okay, so what is happening in their company is they want to give some kind of scores to every video which uploaded to their system. And this scores is related to the usage of the voice, the appearance of the speaker, and also the context, the words that the speaker is using. So at the moment in the system, we have different amazing AI applications that we can give this scores using AI. For example, how was the tone of the voice, or how was the gesture, or how was the complexity of the speech itself. So actually, at the end, what we have in this case, the data that we have here is 20 minutes videos of a speech. So customer is like the customer, our customer is uploading them to the system, and then they are getting some scores some scores from AI and other APIs. So here we see that all our videos have 3 different dimensions, and we generate 3 different features for them. For example, for video-based features, we have like facial expression. For voice-based features, we have like fluidity. For text, we have like filler words, and also we have personality analysis, which is like openness, like extraversion, and others. But it doesn't come from the data. The last one, the personality analysis, comes from the speaker itself. So we are so excited, right? Because here we have a data which has 3 dimensions, and it seems that we can use some fancy things like multimodals, because we have actually 3 different things in one thing. Like we have image, we have voice, we have text. So why not we use like kind of multimodals here, like the hierarchical models, to solve the problem? I'm so excited. But in reality, what we have as a data in our hand, like the annotated data, our train set is only 120 videos. And the length of these videos are so long that the cost of processing each shot of video is so high. Even if we reduce the length to 3 minutes, assuming that it will represent the whole 20 minutes, it is still so costly, and the number of data is not that good, which we can use anything like deep learning here. So, by the way, now going back to the thing that we said, the company, my speaker, is giving scores to each speech. How we are getting those features? We are getting this voice related features, like I said, like tone, the tone of voice, the pause, pitch, these kind of features, using Valossa services. Valossa is an AI company which is providing this kind of like amazing features. And also, actually, I should say that Valossa is giving a very high quality speech to text output, especially for Nordic languages, also for English. So I highly recommend to use it. And then we are using Humantic to get features related to personality, and also there are some features like text-based features that at the moment we are just using some like Python libraries to find them, like the filler words. Also, there is like Python library which gives the score about the complexity of the text. So this is the data that we have. This is the features that we have, and to preparing these features, like we use like this bunch of AI APIs. And so what's the problem here? The problem is predicting Big Six. What is Big Six? Big Six is these 6 labels that my speaker gives scores about those using these features. So one is storytelling, presence, credibility, likability, authenticity. So all those can be predicted actually based on features that we got from AI APIs, which I described in previous slides. So what is our approach here? We have 120 human annotated videos, which we can use as a train set. We can use like tenfold cross-validation here because we don't have like explicit test set. Then we need to assign a score between 0 to 5 for each label. Like storytelling of this video is like 2.5. And therefore, we have like different model for each labels. So we have 6 different labels. We should predict the scores for each one. So we have 6 different models. So the simplest things that I think every bachelor student even could think about that is like linear regression model. So let's keep it simple. So we use that and we got a quite good. So here you see the equation to calculate storytelling score, and result is amazing because we got here you can see a high correlation coefficient in cross-fold validation. It's like 0.96, indicating a good predictive capability of the model. And actually, the customer himself was quite happy about this because he was thinking that he is actually learning something that he never thought about that before, and AI can give this opportunity to them to go to explore new area in their field. So this was case 1, and I will continue with the case 2, which was about the manufacturing company who came to the company and asking for a solution to their problem because they have a huge traffic of business documents, and which come from all over the world in 9 different languages. And there is a big building full of employees who are manually extracting information from these business documents. So they wanted to have an automated process for their company. So there were some challenges regarding to this project. One was that most of these documents were scanned documents, so we did need to use OCR, and we already lost like 10% of accuracy at the beginning. And then they didn't have any backup for some reasons, and they couldn't provide us a training set. And also we did need to we couldn't use like cloud because of security. Couldn't use the like website page annotators to create our own train set, and so we need to make annotator for them also. But at the end, if we look at our AI toolbox, it seems that DNNs are best solution for this. So how we did continue with this? I'm skipping this because I'm going to talk about that later also. So here I will try to summarize what we have done in this case. So we had a bunch of documents in different languages, and then we did need, first of all, we did need to classify those, because not all documents carry the same entities that we would like to extract from them. These entities is like the number of product, the date, the address of the customer. These kind of entities we would like to extract from these documents. But first, we need to classify those, because let's say that type A has different entities than type B. Despite imbalanced data that we had, because the most of documents were irrelevant, so they didn't have any entities. Actually, they were like sending some Christmas card or something unrelated to the business. So we use fast text to classify these documents. Then we send them to pre-processing because we did need to have to clean out this something related to OCR, because OCR provides us lots of errors. We did need to extract information from tables before sending those to our models. So we had two different models because we had two different types of documents. And after getting entities from our models, which I will come to them, we were sending them to the post-processing because customer was requiring a certain standard for saving document. So we did use some amazing language models, which nowadays we can freely access to them, and they are so efficient to use, so accurate to use. And what we used is a Roberta-based model, which we used for English documents, and we used XML Roberta, which is for multilingual documents. We used it for documents which had more than one languages. And performance was great. So the creating model part wasn't the hard part here. The hard part was like pre-processing and post-processing part, and dealing with the requirement that customer had. For example, they had this expectation that they had different kind of like pops up expectation was like we can use NLP algorithms to read those pops up and process them. But actually, the easiest way to handle those wasn't like a complex AI model, and we could handle it just by expert system using a regular expression. So that the takeaway for this is, okay, neural networks are great in complicated problems with lots of data, but classical machine learning methods are still relevant in small data situations. A holistic understanding of machine learning field is very useful in industrial applications. And finally, like applied industrial machine learning is much more than just ML research. So yeah, this is my last slide. And I want to say thanks to Women in Data Science Nordic organization, and especially Galina, who helped me a lot. So thank you.
Thank you very much for your talk, Elin. So we don't have that much time for the questions, but there was one actually about the first use case that you presented. Is it possible to compress a video by a factor of 4 or video, or by 4x speed up rather, so that we can get a 5-minute video instead of 20-minute video?
That's a nice thing. We never thought about that, but I think it could be a good idea. I should ask the expert if this if this will represent the whole video or not, because there are some features, voice-based features, which are important, like the pause. If we do that, are we gonna lose the pause or not? So it depends.
I see. Yeah, that's interesting. Thank you very much.